Hi, my name is Lizzie Stasenko. I'm a rising sophomore at UNC, a biology major, and I'm applying to be a Chem 101 or 102 mentor this fall. The reason I wanted to mentor general chemistry was because I felt like I excelled in the course, and I would really love to help others who are struggling or just need extra practice. And I feel like I understand the material really well, and on a level I can explain it to someone else. And I personally sometimes use the mentors too, and I got a lot of help from them. And I would just love to do the same for other students who need help with chemistry. So, to show how I work out a problem, I chose this acid base problem from exam two regarding titrations and buffers and all that stuff. So, to start off, every time I'm dealing with an acid base problem, I like to look at which chemicals I'm giving and how the reaction is going to work. So here you can see they have sodium cyanide and hydrochloric acid. And question 14 is asking, what is the pH of the solution prior to the addition of any HCl? So first you need to look at just NaCN. So since Na is the conjugate acid, Na plus the conjugate acid of a strong base, it's not really going to react to solution. So we're looking at Cn minus here, which is the conjugate acid of a, or conjugate base of a weak acid. So when this is in solution, you have Cn minus plus H2O. This is the reaction that happens, which yields HCN and OH minus, making this a weak base. So you would treat this like any other ice table where you start with your starting molarity, which is initial molarity is 0.150 for Cn minus. H2O doesn't have molarity. HCN is 0 and OH minus is 0. So then you subtract X because the concentration of Cn minus is going to go down as it reacts. You're going to add X to the right as the concentration of these two things is going to increase, and then that's going to be the initial, it's going to be the change, and at equilibrium it's going to be 0.150 minus X, then X and X. So to solve, you have to set up an equilibrium expression, and I went ahead and found the Ka of HCN. So since this is since Cn minus is a base, you have to use the Ka of the acid to find the Kb of Cn. So this is the Ka of HCN. To find the Kb, you use Kw over Ka. So the Ka is 6.2 times 10 to the negative 10. And you get, just put that in my calculator, Kb equals 1.6 times 10 to the negative fifth. So this is the Kb. You're going to use the equilibrium expression for this reaction right here. So it's going to be 1.6 times 10 to the negative fifth x squared, since the products are x and x, so x times x is going to be x squared, over 0.150 minus x, which represents the the equilibrium concentration of the reactants. So since the Kb is so small in comparison to the initial concentration of Cn minus, and you can figure this out by finding percent deionization, you can just disregard the x, which makes this a little easier. And then you just solve for x, and if you do that, you get 1.55 times 10 to the negative third. And with and then, so this represents X. So the concentration of OH minus, which is what we're looking for here, is going to be 1.55 times 10 to the negative third. And to find the pH, you can find the negative log of the OH concentration. So it actually gives you the POH, which is just the reverse. And then you get 2.810 for the pOH. And this you can subtract from 14 to get 11.190 as the pH. So that is the answer to this problem.